Oh.
And I work in Rhode Island.
Okay, that's why. How far is it to Rhode Island?
Very small states.
I know, obviously. I'm like, he's in a different state. He's not in Massachusetts.
But I get that question. I live in the suburbs, and it's full time. And I'd rather drive to Rhode Island than drive to Boston.
Yes.
Catch up after.
Well, yeah, thank you so much.
Love your pen.
Oh, thank you. Did you move out here for the position as well? Holy smokes. Holy smokes. Yeah. Well, that's, I guess, yeah, so I started, right, but I had 10 years of knowledge of what everybody was doing to understand.
I'm Nicholas DiMancio. I'm the head of architecture here at MIT, and it is my great pleasure to welcome you to the 10th annual Ed and Mary Allen lecture, Edward and Mary Allen lecture in structural design. Before I introduce you to the history of the lecture, I will just read our land acknowledgement statement. MIT acknowledges Indigenous peoples as the traditional stewards of the land and the enduring relationship that exists between them and their traditional territories. The land on which tonight's lecture takes place is the traditional unceded territory of the Wampanoag Nation. We acknowledge the painful history of genocide and forced occupation of their territory, and we honor and respect the many diverse Indigenous people connected from time immemorial to this land on which we now gather. So, this place has many histories. One particular history that it's been my great pleasure to understand over my time here at MIT is the contributions of Edward, or Ed Allen, as I've learned to call him, even though I was never my pleasure to know him personally, to this community and to the larger project of architectural education in this country. I knew Ed a little bit before I came, only because I actually own a great number of the books that I'm about to read out to you from his biography that I'd picked up during the years, not only for their beautiful designs, many by Muriel Cooper, but also for their practical and eloquent language and presentation of the job of the architect and engineer and their work together, which is the best spirit of much of the work that we do here and are pushing here, particularly in our work on climate here tonight, very topically, but also a spirit which I've learned really is embedded in this department as a kind of genius loci of Ed's incredible legacy here. So this lecture, the conversations we've had about it, around it, have been an enormous gift to me in terms of really understanding that tradition and being able to say with great pleasure that I now belong in a small part to it. This lecture brings a distinguished structural designer to MIT each year to share their work in a public forum. It was begun in 2012 with the celebrated engineer Jörg Schleich from Germany, and over the past decade, it has featured some of the most inspiring and creative designers and structural designers from around the world, including Bill Baker, Les Robinson, Sortine C., Janet Eckelman, and more. We're very happy to have Mary Allen and the members of the extended Allen family with us tonight for this lecture in memory of Ed, who is a member of the faculties not only of this department but also Yale, and is frequently taught as a guest at many other institutions around the world. His many books include Fundamentals of Building Construction, The Architect's Studio Companion, The Responsive House, Forms and Forces, Shaping Structures, and more. For all of this, Ed was the recipient of the 2005 Topaz Medallion for Excellence in Architectural Education, awarded by the American Institute of Architects and the Association of Collegiate Schools of Architecture for lifetime contributions to architectural education. Sadly, Edward Allen passed away in July of 2020, but his spirit, particularly his teaching and its focus on efficient, economical, and expressive structures, continues. And this continues, of course, in the spirit of the Edward and Mary Allen Lecture in Structural Design. I am going to embarrass Mary a little bit more by saying she's also a distinguished educator and scholar, having taught biology at Wellesley for more than 30 years, where she's particularly noted for mentoring undergraduates in research. She was awarded the Wellesley College Pinansky Prize for Excellence in Teaching in 1986 and the American Society of Microbiology Karski Foundation Distinguished Teaching Award in 1995. So with that, I would like you to join me in thanking Edward and Mary Allen for making tonight's lecture possible. One of my dear colleagues, Caitlin Mueller, will now introduce tonight's speaker.
All right, good evening, everyone. So wonderful to have all of you here. Small correction, I believe this is the 12th of Edward and Mary Allen Lecture in Structural Design, which is wonderful. We're so pleased to welcome Professor Kate Simonen from the University of Washington to join us here. As you'll see, Kate is an internationally recognized leader in embodied carbon and low carbon structures. I'll read about her accolades in a moment, but I'll just say we've been hoping to have you join us for quite some time, and we're so pleased that you're here with us tonight. So very briefly, I'll read about her accomplishments and accolades. Kate Simonen is the founding director of the Carbon Leadership Forum and the professor of architecture at the University of Washington. She's licensed as both an architect and a structural engineer, and she connects her significant professional experience in high-performance building design and technical expertise in environmental life cycle assessment to spur collective action to bring net embodied carbon to zero through cutting-edge research, cross-sector collaboration, and the incubation of new approaches. Kate is an honorary fellow of the United Kingdom's Institute of Structural Engineers, IStructE, and she was named Engineering News Record Top 25 Newsmaker in 2020 for her impact rallying industry to reduce embodied carbon. Under her leadership, the Carbon Leadership Forum has grown to become globally recognized for advancing embodied carbon data, methods, and policy, as well as inspiring and empowering collective action in the building sector through advances in low carbon data, methods, and policies. With that, we're so pleased again to have you here. I think this is going to be a very exciting lecture. Please join me in welcoming tonight's speaker, Professor Kate Simonen.
Thank you. When I was a graduate student in architecture, which I presume a few of you here are, and you would ask me what would be my best, most desirable job, I would have told you I want to teach structures to architecture students. Why did I want to teach structures to architecture students? I had a master's degree in structural engineering. I sat next to architecture students who knew I had a master's degree in structural engineering, and they asked for my help, and I could not give it. I knew how to analyze structures, but I did not know how to configure or design them, and would have taken me hours or days to calculate and size a single beam in the church that I was designing, when all I needed to know is, did I want a dome or a truss or beams? And I thought there must be a better way. If you would have told me at that time that 30 years in the future that I would be speaking at MIT as a professor of architecture at the University of Washington, I would have not really think that was likely, but it's possible. Yeah, that could be an ambition, maybe. If you would have told me that I'm going to stand in front of you and tell you I'm a climate activist, I would have said, no way, not likely. And if I would have told you I'm going to stand here with a bullhorn on the stage, which I will before the end of the year, I would have been ashamed of my future self. That's what I would have felt at that time. So when I want to talk with you today, I'm going to share 4 different things. I'm going to talk a little bit of some storytelling. And then I'm going to share with you some of my recent academic work. Then I want to have some dynamic conversation and leave with a little bit of call to action. And maybe we might change the order around that a little bit, but something around that in here. I don't travel very much anymore to talk. And I am here today. I'm here today because of Dr. Mary Allen. I am here today because of the experiences that I had with her and as I had with Ed. So as a young teacher of structures, while I was practicing structural engineering, and I was teaching at California College of Arts in San Francisco, and I got flown to a teaching structures and architecture conference. That sounds like a good thing to send a young teacher to, so I got sent to there. And while there, Ed was explaining how to do graphic statics. So I sat in a workshop. Were you there? Yeah. Bob.
Maryland, right?
Was that in Maryland? Yeah, maybe, or I don't know. So, and he explained how to do graphic analysis of structures. I was a licensed structural engineer at the time, and it blew my mind. Oh, no. I see the world in a totally new way. Sometime, Mary and I talked. She doesn't remember me, but I remember her. We were at a conference together, and she sat next to me on a bus. So I sat next to her on the bus, and we chatted. And during that time of chatting, she talked to me about her relationship with Ed and her role as an academic. And I don't think it's, there is not enough diversity amongst the faculty of architecture in architecture programs or anywhere. There's not, when I was a student, it was nearly 50% of the students were women. Yet still today, no more than 20% of the licensed architects in the US are women. I have very few role models of full professor women that I can look forward to and see. And she was one who talked about her career as one of joy and exploration, and it really inspired me. And I remember that to today, so thank you. And it is for that, and the fact, that John asked me to, that I'm here. So I just want to highlight how influential these books are. The Fundamentals of Building Construction, it is not always that blurry, is a foundational reference that if you have it in your bookshelf and you ever want to know what somebody who has 20 to 30 years of building construction experience knows, read the book. It's maybe not, it's very pragmatic. It goes through exactly what's happening. It tells you how to build buildings. I'll tell you, anytime that I read something that I'm an expert in that book, I agree with it, and so I go to it in any place when I'm not an expert. it helps you. And I use it in my teaching, from facade design classes or prefabricated construction. I swear it's my go-to place when somebody is looking to understand conventional building construction. The Architect Studio Companion, my hero. It takes 30 years of experience as a structural engineer and puts it into easy-to-use graphs and charts so you can understand how to design buildings, so that I can teach structural architecture students how to configure structures and work with the understanding the load path and framing plans and estimating sizes in the level that any architect needs to know. How deep is it? How far can I span? And how long is the cantilever? Things that are useful in the early conceptual design stage, and they are useful to structural engineers. Structural engineers just don't get taught that. They're expected to absorb it over the first 10 to 15 years of their practice, and then eventually they will deploy it. And then there's form and forces and the graphic statics. The graphic statics transformed what I see students able to accomplish in terms of analyzing complex trusses in particular, where what went from a mind-numbing geometry, trigonometry problems into something that's fun and delightful and understanding how to shape structures. What I'm going to talk to you today is more about the relationship of structure to the climate crisis and the opportunities for our actions to make a significant difference. So I'm going to go back in time, and I'm going back in time about 30 years when I was the student, and I'm also going to talk about going forward in time. So if we go forward in time, we're in the 2050s. And in the 2050s, we all hope that the world is a better place than it is today, that more people in the world are living in healthy, sustainable, beautiful buildings like we have the privilege of doing here. That as the population grows, that we are able to build and house and educate all the people like we have the privilege of living, and we would have, we've also solved the climate crisis. We are no longer emitting greenhouse gases. We figured out ways to pull it out of the atmosphere and store it in, and we're starting to heal our planet. We have thriving ecosystems and healthy water. We are not at war with each other. We have empathy for difference, all of the things that we can struggle with here. So we look to a future of what we want. And 30 years ago, or 30 years when I was 23, seemed like a lifetime or more, because it was more than my lifetime. It seemed like a long time. But in my 50s, I can see 30 years in the past and 30 years in the future, and I can see things that I know it's going to come faster than we think, and I also know that more change can happen in that time than you could even imagine. I went to college with a typewriter a literal typewriter under my seat on the airplane as I flew off to college, with card keys at the computer lab, and now I can use AI to write my talk here tonight. The things that we do now, and if you would have told us 30 years ago were going to be possible, I would not have believed you, just like I wouldn't believe I'd be standing with a megaphone. So that there is change possible, but it is going to come fast. So I think it's helpful to talk a little bit about how I think change happens, and what change happened to me to make me move from thinking that sustainability, well, okay, I was never opposed to sustainability, but it just wasn't that cool. And I was much more interested in tectonics and structural performance-based design and light and the relationship of light and culture. They were things that were more interesting to me. So you're going to have to, I threw these last more visual slides together, so bear with me a little bit on these here. So 30 years ago, I was a graduate student in architecture, and Mark Webster, who's sitting back there, not liking the fact that I'm pointing at him, he talked about sustainable structures, not all the time, but it was pretty high on his topic of conversation, and I found it endearing. But really? I mean, what is a sustainable structure? I didn't even understand what he was talking about, but that was kind of nice, but it was sort of 1970s and brown. I mean, like, this is 1989. You got to understand the context of my young self. So that's the first I've ever heard of sustainable structures. 4 or 5 years later, I'm working as an architect with Scott. Scott Shell is one of the architects at EHDD Architects in San Francisco, and I got to work on the seismic retrofit of Worcester Hall. So that's my alma mater. That's a beauty. It really is. It really is. And you kind of fall in love with the place you go to architecture school, hopefully. So I really love that building, and it needed a seismic upgrade, and I begged EHDD to hire me to work on the seismic upgrade. So I was able to be one of the 2 project architects on that project, and we're working on it. And Scott was always going around, concrete, reduce cement. We can save the planet, carbon footprint, something like that. That's basically what I heard. And then this whole thing was gonna tip right over and needed a whole lot of foundation work, and like huge piles, like 4 feet in diameter, 50 feet down. They were digging underneath this existing building. And I thought, oh, I wonder if we could put in some of this concrete Scott has been talking about, this low carbon concrete. And I heard it was hard to use because it took a long time to cure. And I was like, this is the perfect place. There's not going to be an earthquake until the concrete cures. So let's try it. I called up. So I picked, this is what I remember. It's 7:30 at night, and I called somebody, or couldn't have been, but let's say it's 4:35, and I called the structural engineer because we didn't have email. And I called him and I said, hey, I got this idea. Do you think we could put low carbon concrete in the foundations of Worcester Hall? And he says, I don't know. And I was like, well, can we just change out the fly ash? And he's like, yeah, probably. And it's okay, could you change your specs? And he says, yeah. And do we have to ask, we talked about it, do we have to ask anybody? No, I don't think we have to. No, I don't think we have to. So he changed the specs on the structural engineer changed the specs, and I felt like, cool. And then I thought, I wonder how Scott's saying that we're going to save the planet with this. I don't know what is it. So I tried to estimate how much carbon savings did we do by changing the concrete mix in those foundations. And I'll tell you, I have no idea how I figured this out, because there must have been internet, but I can't really remember searching for things. But somehow I found the volume of concrete, an estimate of the carbon footprint of concrete, and then I translated that to my commute, by driving. And because I was a bike rider, I rode my bike everywhere, and I'm like, I'm a good person, take public transportation. And how many years of commute savings do you think I could save by changing out the foundation of that one building? 2, 4? It was more than my entire life. I can't remember what it was, but it was, and I don't know if the calculation was right. I'll tell you that. But I was like, whoa, it's a big number. It's a really big number. How can I can make more difference in one building and what is probably about 15 minutes of conversation with a structural engineer than all of my commute choices. So the choices I make as a professional are radically outweigh the choices I make as an individual. And that was an aha moment for me. Then Ed Mazaria. I was at another conference where Ed was talking, it must have been right around 2005, and he issued the Architecture 2030 Challenge. And I'm trying to channel a little bit of Ed, because he got you all getting going. He was like, you're gonna sign the 2030 commitment. You're gonna go out and make a difference. Well, this was in 2005. 2030 was 25 years ago, and you were 25 years in the future, and all you had to say is you were going to make your buildings net zero by 2030. Of course you could do it in 25 years. And so I had my own practice at that time. And so I adopted the 2030 commitment, which meant that I had to make all my buildings a little bit more energy efficient at the time. And I told all my clients that I was putting another ½ inch of insulation in their walls in those residential buildings, and it was pretty easy. But I'm gonna do that. I then around 2008 was with a group, Ben and Phil, and we were looking to start a green prefab housing company. We managed to have one house made. That's not a company. That's one house made with prefab medical studs. But we had a plan that we were going to make a glass and aluminum curtain wall in Asia, where we had some contacts that could make some high-quality materials and for low cost, and then we're going to ship them to Hawaii and California and snap them together and make net zero energy homes. So that was a green company. But can you do that? And is that green enough? And so we asked ourselves that question. Other people asked their question, how could you do such a thing? And that then led me to try and, well, what is the impact of making glass and aluminum in China and shipping it to Hawaii? And is it better or worse than making something Hawaii's a unique case because they have to ship almost everything there, but what are the other options? And that led me to ask, again, what is that embodied carbon impact? What is the impact of making those building materials? And I looked again to try and find out what those impacts were, and I couldn't really figure them out very well. I could get some estimates, and I tried to estimate them, but I couldn't act, or I wasn't confident. That group, we committed to calculate the embodied carbon of our buildings, make the clients pay for the transportation offsets, and we'd pay for the, I don't know, we had something that we were gonna do, but we tried to launch the company in 2008, and the economy collapsed, and it's not a time to start a housing company. I don't think it would have gone anywhere anyways. We were missing some key parts of a successful company. So I'm gonna go back to that one. So I joined the University of Washington this was basically my first research activity because I was doing the research and development to how to start a company, trying to figure out life cycle assessment methods. I had a lot of fun with asking all those questions, and I wanted to keep asking questions related to practice. So when the opportunity for faculty searches and structures came up at the University of Washington, the University of Oregon, USC, Cal Poly, and Woodbury University. That was in University of Denver. 6 structure searches in the same year on the West Coast. Nothing against the East Coast, but I would never come here to live. And so I'm only going to look for structures positions on the West Coast. And look at them all. This is like a sign that I need to apply for those positions. So I took a position at the University of Washington, and I'm missing the next slide, which is a group of 9 or so, structural engineer, material manufacturer, concrete manufacturer, general contractor, had gotten together, and they met once, and they decided they wanted to be able to specify low carbon concrete, and to figure out what to do, and so they chose the name the Carbon Leadership Forum. I joined the University of Washington, connected to them and said, what are you doing? And they said, we want to meet a second time, but nobody's organizing anything. Will you help us out? And I said, yes, I will take the Carbon Leadership Forum and move forward. So the first 5 years of the Carbon Leadership Forum was mostly a group of small individuals who came, 5 to 20, who met about once every other year and shared best practices of integrating life cycle assessment into practice. That would be like Francis Yang at Arup, who was an early leader, or Don Davis at MKA Structural Engineers. They were the competing structural engineers on the West Coast on that topic. This slide is from around 2014, where we got together and we made barriers and actions to overcome those barriers, and we mapped out the things that needed to happen. And it's super fun to look at it because we've gotten a lot of them done in the meantime. We were meeting and seriously, I would call us earnestly thinking about embodied carbon and life cycle assessment. Maybe it went up to 25 people. And then it was around 2017. We're working hard. I'm working hard. I was tired, and we're working hard. And it was going to come up to 2020. And then we were going to have been working for 10 years, working hard. And then I look at 2020 to 2050, and so do I want to keep? I want to work. I want to make a difference. And then I would reflect: how much have we made a difference? How much change has happened in the planet because of us working hard to estimate the carbon footprint of the structures? And I would argue none. Nothing had changed. Nothing had changed. And so we could work hard and be better at counting how much carbon had happened, but we wouldn't have made a difference. So. It was around that time that I started to take more risks and in order to have a larger impact. Stacy and Phil had come to me with some ideas about how to get data out of environmental product declarations, which were PDFs and clunky, and you couldn't figure it out. They had a good idea about how to compile embodied carbon data. Don and I, who went to graduate school with Mark and I, Don had some good connections to a potential funder, and we pitched to create an embodied carbon construction calculator tool, and we got funding for less than 20% of the total amount, and then we announced to everybody that we were going to do it, and we just kept doing it and raised money the whole rest of the way. That was stressful. We, building on Architecture 2030 Challenge, worked with Catherine DeWolf and some others to launch a challenge for structural engineers, which has now grown into the Structural Engineers 2030 Commitment Initiative out of the American Society of Civil Engineers, Structural Engineers Institute. And so we're looking at, the orange band is the reduction in carbon emissions from architects, the blue band is from the structural engineers, and the green is from the systems engineers, looking to getting to a total carbon reduction. So and I have Julie Janinski's over there, who's a great leader on the MEP 2040 commitment. And then we additionally empowered the creation of regional volunteer hubs. So there's Carbon Leadership Forum hubs. What do we say? Oh, that's kind of an exaggeration. That's our database of people who get our newsletter. So that's not the hubs. I'm sorry, that's a mistake. I grabbed the wrong image. But there's Vancouver, Boston, Atlanta, Omaha, Alberta, and talking with Kenya. Huh? LA, Pittsburgh, Chicago. Yes. So it's about 20 different regional hubs, and I think there's some other regional hub leaders from Boston in here today. They're back there. Yay. So Boston is actually one of the leading areas for embodied carbon action. And so the Carbon Leadership Forum in the last 3 years has grown from a staff of 3 to 17 of a current staff, and then we have students and our volunteer leaders as well. So how am I doing? Okay. That was my fun story stuff. Now I'm going to go and give some slides that are more about the work of the Carbon Leadership Forum, and I'm going to go through that. I think I'm doing okay on time. So I won't try and rush too much, but it's a range of some of the work that we're doing, and then have some time for some conversation. So at the Carbon Leadership Forum, our mission is to eliminate embodied carbon in buildings and materials as an infrastructure to create a just and thriving future. It really was not that long ago that I would not have been confident enough to say that a goal to eliminate embodied carbon was even possible. I would have said that would have been an overly ambitious statement. And I tell you, I don't know exactly how we're going to eliminate the emissions from making building materials, but I do believe it is possible. So what is embodied carbon? Embodied carbon is the emissions from making building materials across their entire life cycle. It's emissions from driving trucks to extract raw materials. It's the emissions from chemical reactions at a cement factory. It's the emissions from the electricity production used to make the factories run. It's transporting to the site, using and repairing materials over their lifespan, deconstruction, end of life, and then ideally not deconstructing and end of life, but deconstructing and reuse in a circular approach. Global greenhouse gas emissions are, if we're meeting Paris targets, we're capping in the next 6 years, and so we're starting to go down, and then we're down at 0 by 2050. And so that means that all sectors of the economy need to be addressed. So what initially from the building sector had been focused is that 18% of building emissions, because that looks really huge. And if you look at the making of building materials, then you're talking about industrial emissions, so manufacturing from factories. And there, just iron and steel production and cement are nearly 15% of global greenhouse gas emissions. And then on top of that is carpet, ceiling tiles, sheetrock, et cetera. And those materials also are transported in how we move them around. So if you can cut your pie in a whole lot of different ways. But in any case, if you're looking to decarbonize the industrial sector, cement and steel are key. And if you want to decarbonize cement and steel, the buildings are primary drivers of consumers of buildings and infrastructure are the primary purchasers of those materials. So the building industry is seen as a major part of decarbonizing industry. From an architectural design perspective, I'm not arguing that it's not an embodied carbon versus operating carbon battle of like which one's better or more important. It's a total life carbon reduction, so that needs to take a comprehensive approach. Another way of looking at that is on this time chart where the building life on the horizontal axis and the vertical axis is carbon emissions. We get a large upfront burst of carbon in yellow here at the construction of the building, and then the emissions in operating occur over time. And here we're indicating that electrical emissions are expected to go down as we decarbonize the electrical grid, there's not a way of going back and retrofitting out the upfront emissions of making the building. And then wanting to highlight that I'm talking about greenhouse gas emissions, and I'm talking about the equivalent carbon emissions from those in language when we're also talking about all of the other emissions that take place during the manufacturing processes. So the life cycle assessment as the method to evaluate embodied carbon tracks other emissions such as particulate matter or waterborne emissions that cause algae blooms. So there are many regional and local effects that a focus on supply chain and total emissions impacts come into play. And in particular, where the manufacturing happens, there's direct impacts to the people that are surrounding the manufacturing. So I see one of the advantages of life cycle assessment is a responsibility of looking back down the supply chain to understand who's making the things, how they're making them, and what is the impact on the community. And it makes a stronger connection between the buildings that we build and the materials that we use and the people that make them. Embodied carbon emissions are possible today. I typically talk about three main strategies. The first one is just build less, reuse a building, build half as much building as you need. A building that is half the size of another building is going to use essentially half the materials and half the related embodied carbon emissions. The second category is optimizing system. This is where you try and say, should I build my building out of mass timber or concrete? Should I really have that cantilever that cantilevers out 453 feet, or could I have 3 columns underneath them? Maybe. Or maybe I could use a form-active structural slab, as I heard earlier today, or form-active foundation systems. Can I design for disassembly? So all that's really the design and detailing space. And then the third type is on optimizing procurement. So I know I already need to buy concrete, or I know I'm going to buy steel. Can I incentivize and purchase the lower carbon option? And so when talking about this, we'll often talk about materials approach or a buildings approach. And both, they're not in conflict with each other. An optimized building would be taking both approaches, that we choose to build the smallest building possible, or we renovate an existing building. Instead, we optimize how much materials we use in making the building and how they will perform over their total life cycle. And then at the end, we choose to prioritize purchasing of the lower carbon options of similar things. You could also think of embodied carbon from a circular economy principle, that from the very beginning, where do you think about where you build, how you build, then exactly how you, where you build, how you build it, what you do with it when you're done with it, and then what do you do with the materials and at their end of life. So as Catherine DeWolf talked in her talk at Harvard today, she talked a lot about circularity principles and really being able to close that gap of when you're done with a building, how do you turn the results of that no longer needed material into something useful for somebody else, and what are the social and economic barriers to that work. So I'm going to go through a couple of different projects, and now I'm going to be channeling my team. So on each of them, I'm going to highlight them with the team member who's leading that work. So the first one is around the version 2 of the benchmarking study that's being led by Brad Benke. This builds off of work that I did with Catherine. Here you can see one of the graphics from a paper we wrote for TAD, the Journal of Technology, Architecture, and Design, in which we should brag a little bit. We won an award on that paper. It was Best Paper Award, and which gave that work. You can see all those little dots. See how wide the spread in all those little dots are? Like on public assembly is between 100 kilograms of CO2 per square meter and 935. So from this result, there was difficult to draw any very narrow conclusion findings, but by the result of the study, I can now tell you the order of magnitude of embodied carbon. And so before that study, I wouldn't have confidence to be able to tell you that the range is normally between 200 and 900 kilograms of CO2 equivalent per square meter. The second study now is collecting a fresh round of material quantities for both structure and architecture, and ideally interiors and mechanical systems, with the aim of being able to update the benchmarking with more deep resolution of detail so that we can dive down into understanding the impacts of different material choices at a range of different scales, and have a data set that we can analyze more robustly than we had from the previous one, which just collected a single data point for each building. Two. Embodied carbon, three. Embodied carbon, area, floor height, height of the building. And then we're also working to collect operating carbon emissions so that we can get towards total life carbon. We're expecting preliminary results from that in early 2024. The material baselines, this is the third issue of the material baselines, where we're issuing estimate of the typical embodied carbon per specific materials. This was developed in support of the EC3 tool. Brooke would be telling you how he worked to evaluate environmental product declarations or databases from industry trade organizations and manufacturers, both to describe and categorize different material types and understand and report a reasonable baseline. The exciting part, in my opinion, and I think he might agree, is the appendices. So if you're a materials geek and you want to kind of go in to understanding embodied carbon of materials, I highly recommend these appendices. They dive into things about the relative impacts of the different life cycle stages from key manufacturing. So the top one is metal steel decking, and you can see that the majority of the impacts are making the steel. That's A1, and A2 is driving the steel to the plant, and A3 is rolling it out into little corrugated steel decking. So the major impact is from making of the steel. This is on insulation, and you can tell that if you only use cradle to gate, the blue ones, emissions, they'll often look the same. But if you include the off-gassing and the blowing agents from some of the different installations over their full life cycle, you get a whole another order of magnitude of impacts. And then diving in, then we have data on the number of EPDs, the values of the emissions for those different manufacturers. So this one here is for some different concretes and the number of mixes in different strengths categories and carbon footprint. Oh, this one's really fun. I'd have Megan Lewis and Brooke Waldman here today talking about advancing the LCA data ecosystem, a policy-focused roadmap for reducing embodied carbon. This grew out of an EPA I, request for information, in which the EPA was asking questions about life cycle assessment data. And we started first in convening a small group of stakeholders to answer the EPA's RFI. So we had a, 40-page response to the EPA's RFI. And we wanted to translate that into something a little bit easier to read and interpret. And so we convened a large group. I don't know, do I have the number? I think it's like 25 different people on several different workshops to understand and build consensus around where are the weaknesses within the current LCA ecosystem. And we're doing that primarily because the growing use of embodied carbon in policy. We've got embodied carbon in policy all around the Boston region. It's stunning, actually, the number of small towns that have embodied carbon regulation in Boston area. Go, hub. Woo! Coming out through the federal government, through the Inflation Reduction Act and the Infrastructure Something Act, there's a lot of focus on use of life cycle assessment. And so that means at the present, we're shifting away from what were voluntary use of a life cycle assessment. So most of the work in the past was individual firms or private building sector owners who were asking for low carbon materials and solutions. Now we got the federal government going out to bid on projects and awarding incentives for lower carbon solutions. There's a closer look and need to have more clarity about the strengths and weaknesses of the data that's behind it. And through that, we've outlined a roadmap of how to improve embodied carbon data. There's a EPA grant out for $100 million due in January to help manufacturers develop more robust data on their products to support that policy, but also LCA methods and standards around that. This is Megan Kalsman. She would tell you about her work with the PCC, so the Pacific Coast Collaborative, the governors and of all states and provinces along the West Coast, BC, Washington, Oregon, California, got together and with mayors of major cities across those regions to create the Pacific Coast Collaborative towards advancing strong climate solutions. And one of them has been focused on embodied carbon. We worked with their embodied carbon task force, and this is developing some policy case studies. Those are case studies that include things from climate action plans to building codes to zoning and policy, and down to deconstruction and reuse. And we're right now in the process of developing an East Coast policy case study coming out. And I didn't mention in my broad theory of change of scaling of being more uncomfortable, like taking risks of projects that weren't fully funding and committing to answer them, and I'll tell you, empowering regional hubs to speak with a CLF slide that I don't know everybody who's doing what they're saying, and we're not checking every single thing that they say. That's a risky scenario. There's sometimes, right? And then a policy is the third place. So I was, if we're really going to make a difference at the speed we need to have public policies in place that incentivize and reward good actions. And in order to do that, there needs to be technical support for policymakers to make those choices. It's been a really fascinating experience for me over the last 5 years, understanding how policymakers understand about it, learn about a topic, invest the time in it, and position themselves to have legislation in place. So the work that's happening now, that's coming out through the Inflation Reduction Act, there's been people working for the last 6 years with a goal of influencing industrial decarbonization policy to frame up things so that that can be in place to happen. So there's, oh, I'm talking fast, so we can have conversation. That's okay, right? Yeah. So so there's more things on the Carbon Leadership Forum website in terms of resources. If you're the Architect's Toolkit has 2 different parts. I put that on the side there, or 3. Introduction, measuring embodied carbon, and strategies to reduce embodied carbon. And so that's really designed to be an entryway with the idea that open for all architects to understand. There's policy toolkits and trainings for policymakers. you might go to your hometown and ask your zoning, your planning commission whether or not they have any embodied carbon policies. Working on an infrastructure toolkit, and then, as I said, there's regional hubs. We have an online community where people can ask questions and answer questions, and a monthly newsletter. There's more. There's things that happen. Lots of things are happening. There's also a really, it's a really exciting time. And I would say, so I'm going to advocate for a total carbon perspective in your work. There's all sorts of different places. These questions aren't answered, and there's lots of interesting questions to answer. And there is only going to be growing understanding and awareness and interest in answering those questions. And as I started out, I talk about change, and I think about change really only happens when you have people finding the place for where they have agency to make the change. So when I was an architect, my agency was on that one building, and the rest of my other work was nothing. Well, nothing related to carbon. I had a lot of fun and interest in figuring out what colors you want to use in a middle school library, and where do all the light switches go, and how do you make a building work well? I'm just how do you make a bathroom work? I'm just trying to talk about the regular stuff of architecture is interesting, and it does. Yet simultaneously, when in each of those places there's some place to act. So I've got some of my guests who've agreed to say things to me, help me out here. So I'm calling on Mark first, because he's a dear old friend, and I kind of want to embarrass him a little bit, because he's not necessarily but he's. I just find it really interesting who brings up an idea when it's not cool, right? And not only is it not necessary, it wasn't. He didn't just bring it up once. He's kept on bringing it up. Yeah, like he kept on bringing it up. So, so Mark, I want you to give some advice. What was the hardest part? Maybe that's what was the hardest part about advocating for sustainable structures when people like me didn't understand what you're talking about?
I guess I'd say just learning, like first educating myself, just to have something to talk about, right? Because back then we didn't really know, we didn't have what we have today with all the resources around sustainability and so on. So I think, if you're passionate about something, you just start talking about it, and that's always worked for me. I'm kind of thinking there's like, I think 4 things. There's learning about what you're passionate about, advocating for it, connecting with people, and that could be like trying to find other people who share this interest, and maybe the last thing is educate others. Once you've learned, is educating others. So I think those are sort of the lessons I've had through my life. And I mean, it's amazing that, something I did way back in college has now somehow in some small way contributed to your path. And I think throughout our lives, those things just kind of happen. You don't know when. But if you're out there talking about things and talking with your friends and just exploring these issues, they do happen. Mm-hmm. So I guess that's what I would encourage. And, maybe if it's just to give an example, when I went to SGH, in the late 90s, and nobody was really talking about sustainability again, like usual. But so just having to find, connecting with those people in the company just by putting the word out, and we formed like a little internal sustainability committee, connecting with the architects at the Boston Society of Architects, BSA, had a committee on the environment. So there was nothing going on in engineering, but I could go out to the architects and discuss these issues with them. So the word kind of got around in the company, and I also was connecting with other engineers around the country at that point and started up a Yahoo user group just for people to converse about these things. So that was all great. Things seem to be slowly changing. Then one day, Don Dusenbury, who is a principal at SGH and really involved in SCI, came up and said, SCI wants to start a sustainability committee. Would you be interested in getting that going? I was like, yes, here we go. And connected with Dirk Kestner, who was also working at SGH at the time, and we started the committee. And now it's like one of the most active and biggest committees at SCI. It's just fantastic. So maybe that's just another example of how maybe using those four rules, things happen.
What were those 4 rules again?
So I actually kind of thought of there's even an acronym. So LACE, L-A-C-E, learn, advocate, connect with others, educate those who,
Okay.
Once educate other people.
Awesome. Thanks,
So,
Mark.
Yes.
Okay, and I want to go on. I'm not supposed to do that. I could talk like this, yeah. So I'm talking about total life carbon. Julie Janinski, Bro Hoppold, MEP 2040. Yeah. What do mechanical okay? Why are you doing this? What are you doing, and why are you doing it?
How long of an answer would you like to that question?
About like what Mark did.
All right, great. So I would say the first time I came across embodied carbon was 15 years ago in a master's program at University of Sydney. Didn't do anything with it until about 10 years ago when we were working on the Atlanta Stadium, Mercedes-Benz Stadium in Atlanta. Bro Hoppold was doing the structural engineering for that project. I was working with Roderick Bates and Steph Carlisle, who's now, Steph is on your team. And they had just set up the Tally program, and they were looking for people to try to beta test this idea. So our first LCA was on massive stadium, which I would not recommend. Choose a smaller project for your first study. But learned a lot, tons about carbon, fly ash, et cetera, et cetera. And as we started to continue down this journey, we made a really clear connection between all of the impacts that structure can have, as well as facade and interiors and systems, and sort of put our hands up and said, hey, who's working on mechanical systems when it comes to embodied carbon? We know what the energy looks like. What can we do in the embodied carbon space on this? What does it mean for a project to think about every single system and not just structure and facade? So we got together with a couple people from my company and a couple people from a handful of other companies, very passionate on this topic, very similar to Mark's enthusiasm, and sort of asked each other, like, what can we do about this together? And because SE 2050 existed and Architecture 2030 existed, we had this idea of a format, and we talked to you and your amazing staff at CLF about what the MEP community, what the systems community could do to try to tackle this question. I would say I don't have an acronym for for anything like this, but somebody else came up with one, and now I don't remember who to credit. There's a project going on right now called ECHO Project. It stands for Embodied Carbon Harmonization and Optimization Project. And I think Vince Martinez from Architecture 2030 put it best when he framed it in the idea of radical collaboration. So not only are we talking about whole life carbon when it comes to embodied and operational, we're also talking about it from discipline to discipline, structure, facade, systems, interiors, et cetera. We're also talking about it across all of those organizations. So for the first time ever, Architecture 2030, SE 2050, MEP 2040, we will figure out the years, don't worry. ASHRAE, USGBC, ILFI, I can't even remember all of the organizations, there's like 24 of them, all came together in the same room to have a conversation about how important it is for us to use the same language so that we can answer the whole life carbon question. And we're so excited to be at the table.
Thank you. So if you're getting the idea, my theme here is about people and connections, right? Where does action happen? the peers that you meet here are your future collaborators, just as elsewhere. I was asked to be on Catherine DeWolf's PhD committee because of our shared interest in embodied carbon, and I really wanted her data. She like, you know, we have 1,000 buildings in the benchmarking study. How many did in yours on structure? It's like 400? Huh? 600? Yeah, she's the vast majority of in her work in collecting structural material quantities and embodied carbon. Catherine you gave a great talk at noon at Harvard, and I noticed that I had never been to Harvard, but I had been to MIT multiple times. That's interesting, right? That wasn't a conscious choice, but it does appear that interesting things happen at MIT because I come here. So, Catherine, could you talk a little bit about benchmarking in particular, and what you think is the value of benchmarking, why you did it to begin with, and then what about benchmarking a circular economy?
All right. Maybe I'll stand around. So I think when we started benchmarking embodied carbon, we knew about how to calculate operational energy of buildings, more or less. I mean, there were still some debates on how accurate that was compared to real life and simulations. But it was pretty clear how to calculate it. And embodied carbon was not so clear yet how you calculate that. And then people kept saying, like, my building is sustainable or my building is green. And then you have these things that you mentioned also in your talk when you were building your first project as an architect, where you're like, well, how sustainable is it really? And how can we measure that? And how can we avoid that we do greenwashing, right? How can we avoid that we just say it's sustainable because it looks sustainable, it uses some materials that look sustainable, but how sustainable is it? What is the exact embodied carbon? And that's why I thought it was important to benchmark it, because then once I started learning how to do the life cycle assessment, which I did thanks to reading your book, and so basically I was like, okay, so is this a good number? Is this good or bad, or what do I compare it to? How do I compare a building to another building? Can I compare it apples to apples? And so that's the whole reasoning why I started benchmarking. And so now I'm working on circular construction, which is kind of like the first thing I did in undergrad, was looking at sustainable waste management of buildings. And so now I'm trying to turn waste into wealth, applying circular economy principles. And I'm facing the same problem, which is everyone wants to say their building is circular right now. But what does it mean to be a circular building? What does it mean to be circular? There's principles of the circular economy, but how do you measure how circular you are in the spectrum of actions that you can take? And again, here, there is a need for really measuring it and objectively being able to say what is circular. But there's no good answer to that question, because right now we don't know how to benchmark circular construction. There's no consensus on what it exactly means and how you exactly measure it. So here is an opportunity for research, and so maybe another PhD on measuring circularity, which is what I'm doing currently also in my lab. I'm working with researchers who want to take on this question on benchmarking circularity, because there's no answer right now. We don't know how to measure circularity. It's a concept, but it's not a thing you can measure precisely in a holistic way and where everyone agrees and there is a consensus on what it means. So, opportunities for research.
Thank you. I think, thank you. It is so fascinating when you don't know, when there's not knowledge. So I just want to emphasize, I had the exact same thing with my first life cycle assessments. I ended up having like 10 students do a life cycle assessment of the same building, and they all got radically different answers, and I had no way of knowing which one was approximately correct because I did not know the order of magnitude. I mean, I seriously didn't know whether or not it was 100, 500, 2,000 kilograms per square meter. So that study got us an order of magnitude, and that's the same sort of thing. Is a circular building 100% reused or 10% reused, right? And do you measure by mass or money or?
Do you measure reuse? Do you measure regeneration?
Oh yeah, like and how like what do you give like partial credit for things that you melt down and other yeah.
Like do you give the credit to the one who gave the material for reuse?
Oh yeah,
The owner
yeah.
is reusing the material that
Yeah. Who owns it?
So there's so many questions. It's like 10 times more complex than just embodied carbon.
Oh no, it's not more. My stuff is more complicated. That's just simple. You building stuff.
The embodied carbon of reused structures
Is very complicated.
than
Yes,
linear construction.
and yes, I'm teasing you. So the if we this has been a really it's been fun. I promised I'd bring out my megaphone. So so what's my megaphone here for? It's a prop for me to be brave. It's a prop for me to say, here, John. I want to talk about the first answer. I'm still going to talk about the first answer. Has anybody seen the movie, the video, YouTube video about the crazy first answer? He's standing on a green field and he's dancing, and nobody dances with him. That's Mark. This is Mark. Dancing. Nobody's paying attention to me. And then there's the first follower, the person who comes after him and starts dancing. And then eventually the whole crowd is dancing like crazy. In different communities, you all have the opportunity to be the first dancer or the first follower. And you could also be that crazy crowd just going on for fun. If we're going to make a significant difference in terms of mitigating and adapting to climate change, it is going to be the arc of anyone's professional career. It is going to be the driver of social and economic change, and it is going to be the driver of architecture practice, no matter how you think about it. And so your role in that change, I challenge you to have it to be one of optimism and persistence, that you and find where your role is. It doesn't have to be the person holding the bullhorn, and it doesn't have to be the person who spends all of their life researching circular economy. It can be somebody who's fascinated by AI or who is delighted in color or computation or speed or robots or fabrication or culture or history or anything, right? We all have the places that we're going to fit. But I will tell you that the opportunities within a climate action space are huge, and the opportunities, no matter where you are in the world, they will have different roles and different responsibilities. And I have the book that I was supposed to bring. The Future You Choose by the architects of the Paris Climate Agreement, somebody Karnak and somebody else, because I forgot my book at home, so I'd hold it up here. But they have a really great, so I'm going to try and paraphrase what I find as a really motivating point. They said, we need to, in the next decade, we need to have emissions, and then we need to get us down to 0 by 2050. And when we look to the past and our parents' generation, they really didn't have the opportunity because they didn't have the technology, the capital, and the, well, I'll give them a little bit of a push. They didn't have the will either, right? But they didn't have the technology and the resources to make a change. And for our children, it will be too late. This is the time for significant action to happen, and it is in these next decades that we make a difference. And sometimes I can be very optimistic and say, yes, we must all move together and make all this change happen. And then sometimes, and that we can do it. I know it's possible, but will we? And then I can get depressed and think, oh, look at this, we're fighting with each other when we should be coming together and solving problems. And the only choice that I think we have is to have faith and optimism in the opportunity of people and our native goodness to not individually, but as a collective whole, that we will continue to do better over time, and that we all must do better over time. So I guess my hope for you is that you do not despair when things seem hard, and you look for where you can make a difference and take advantage of where you have agency to make that difference in whatever way you find. And when we arrive at 2050, I doubt we have achieved the picture of the future that I would like. I think that's not likely. Just like 50 years ago, we were not, we're going to keep changing. But it's only through that consistent persistence that and an optimism of the faith that we can make it better that we will. So I think that's my ta-da. That's my attempt at embarrassing Katie of 1989. So.
Wow. Kate, thank you so much for such a positive and inspiring and galvanizing experience for all of us. I think this was a really special and unique way that you shared all this wonderful work with us, and I think we're all very excited. We have time for a few questions or comments from the audience. I'm going to start with Professor Nicolas Desmonchaux.
You don't need to sit, but you're welcome to. Thanks so much. That was an amazing lecture, and really, really inspiring. It showed both what Angela Davis called both optimism of the will as well as optimism of the intellect. So I really appreciate it. I think we're here in a university, in an architecture school, and your talk. And obviously this work of the Carbon Leadership Forum really focuses on real-world impacts through practice, which you spoke very eloquently to. Yet you're also a very distinguished architectural educator. And so presumably reimagining practice involves reimagining the education that leads to that practice. But I'd love to hear you talk a little bit to that challenge, which is one we have here, and also the optimism and opportunity we can bring to it.
That's a good question. I think one of the things that is so strong about universities, and that I learned through getting a tenured position and figuring out how to create research that qualified within the realm of university, and is appreciating the role of the university to generate and preserve knowledge. I see that the foundations of the university and the structure of universities are around generating and preserving knowledge. And so they're not actually designed as institutions to be able to make radical shifts in how we do things. And so then when you're faced with a time of big change, it's very difficult against an institutional structure that was designed to preserve knowledge over the long term. And I can really appreciate that because, well, when I first started learning, I just wanted to learn. And I just wanted to learn. And I was researching to learn, and I'd figure something out, and I was so excited, I wanted to move on. I'm done with that. Let's move on. Then I'd move on. And so there are things that I researched and I learned, but I didn't take the time to write a journal article to publish about them. And they're lost now. I can't remember them, I can't reconstruct it. And so I learned something, but that's a selfish act of learning. That's not a transmission of that learning to a broader position that other people can learn from. And I think as we look on an uncertain future in the scale of centuries, that preservation of knowledge is really important through times that will be more or less stable than they are now. So I use that as a way of appreciating how difficult it is for an institution to change. And then appreciating that it's by design. And so what do we do when we work within institutional structures that are designed to provide us with stability, yet we need to be nimble enough to change? And I think I was reflecting about that Ed and Mary were at Berkeley during times of radical change in the late 60s, and the impact that had on education, and recognizing that I was taught by educators who were young faculty members during that time, and how difficult that was for them, and how it led to somewhat a reactionary perspective. So in that context, to answer your question, I think that the amount of change is larger than we can appreciate, because it's sort of like molasses covering something that you're not paying attention to. It may seem like it's really not changing, but it is changing in a way that it's hard to understand. And that can be, I think, more difficult to understand from a student perspective, because it's like, why am I being taught the same thing that was taught 5 years ago or 10 years ago, or that this person isn't, I don't know, I'm sure that's not happening here, but sometimes it can feel that way. But from my perspective, it's absolutely stunning, the amount of change. So I'm just going to talk from life cycle assessment and embodied carbon. 5 years ago, I could name all 33 people doing life cycle assessment. I mean, it's 5-6 years ago, probably. It was really 33 people doing life cycle assessment and embodied carbon. When we brought the EC3 tool to Greenbuild, we did a concerted promotion event, and we got people going, and we gave out little pins, and that was like the buzz. It was the hot topic. You go to Greenbuild now, there's people talking about life cycle assessment and embodied carbon all over the place. There's people doing stuff. They're doing things. What's happening in universities in terms of total life carbon across the U.S. is really quite stunning. And I would argue that practice is probably moving faster than academia in many ways, and that's okay too, because the students are the fresh flow of energy that comes through that spices things up, and it's what you learn from each other and what you teach the faculty and what they teach you that all kind of comes together to make a culture. So I don't know. That's my answer.
Maybe 1 or 2 more questions. Juliana?
Yeah, I have it. This should be on. Great. Thanks so much, Kate, for your talk. It's a motivating talk to hear at the beginning of a PhD that's focused on this topic. So I'm curious about, you draw this dichotomy between a buildings approach and a materials approach. And one, I was wondering if you could first just talk a little bit more about the relationship between those things. Are they in opposition with each other? Are they in parallel? Do they rely on each other? And then 2, my understanding of the way our built environment and linear economy has gotten to the way that it is has to do with design, partially designers and engineers being slightly disconnected from the origin of materials in buildings, and specifically materials in structures. And so I wonder, by drawing a different approach to kind of both of these things, do you continue to kind of lose this attachment on the design side to materials when talking about a sustainable transition.
You lose the detachment?
No, I'm saying if you draw a dichotomy between these two approaches, is there a risk of like trying to reconnect this aspect of valuing materials on the structural side?
Okay, so I do think there is a risk. I think some people are focusing only on a materials approach and are missing the systems approach. However, I also, there are different places in the design and construction decision-making process, and there is different, in particular from a policy perspective. So policymakers have an easier time understanding a procurement-based approach to procure lower carbon building materials because they can draw the connection. I want to decarbonize industry. I want to reward the company that lowers their carbon footprint, so I want to buy lower carbon steel. That's like a direct connection point. And we've spent, by talking about a material and a buildings approach, a lot of that conversation on our end is with policymakers and trying to explain to them how that why they're not different and they have the same objective, and that they're complementary, and that you need to do both. So we will have policymakers who say, well, I've addressed embodied carbon by a buy clean policy, and therefore I don't need to talk about it anymore. And then we talk about the scale of material use and all the other options. So I think even just no, I don't. I think it's helpful for us to be able to describe them as different approaches, and then to take from one person who's approaching one and say why you need to move to the other, include the other, and yeah.
Awesome, thank you.
Maybe one more question. Oh, wonderful. Yes, please.
Okay, hello, thank you so much for your presentation. I had a question towards the social and kind of political part that you spoke about. And I was hoping to ask any advice you might have, as I'm currently in the MRC2 at GSD, and we're talking a lot about how adaptive reuse and carbon footprint can specifically help marginalized communities, specifically low income, immigrant, etc. And like, what would be some advice you can give in terms of how we can kind of initiate proposals or projects that are specifically tied to helping these communities in need, when it seems that a lot of the times those resources are not necessarily allocated to those marginalized populations? So what, some motivation or some advice you might have in terms of how to stay optimistic in bringing in these technologies in the most needed places in the planet.
Thank you. So you're going to end me on a hard question that's not in my immediate domain expertise, but I'm going to attempt to answer. So I think the first question that one needs to ask is understanding what are the interests and values of the community themselves, and what are their priorities? And so priorities might be jobs, priorities might be clean air and lowering asthma risk, it might be healthy homes or lower energy bills, right? So I would say that personally, I find myself challenged with a perspective that tends to think that I know the answer and I know the best solution. And so I think that that means it's harder work to understand what a community's priorities are. And when John and I were just talking a little bit about that society needs enough space in it for us to appreciate all these other opportunities. When lives are so hard that you are working 12 hours a day and you're worried about your children safety and hunger, whether or not you're going to worry about lower carbon insulation materials seems low on the likelihood. And so I think then that would put into, from a social political perspective, how do we structure our society in terms of providing space for all people to have the time and energy to think about things such as health and beauty in our buildings, right? And you know, that's a place that I have seen glimpses of in parts of my life, and I would like all people to have that space. So to me, that talks about voting. You know, if your generation voted at the same pace as the baby boomers voted, you'd have a lot of influence. So I'm not saying you're not voting, but you might know somebody else who isn't. And it can feel real, you know, my voting record was not as good in my first 5 years of voting than it is after that. It was hard to vote while I was in college. I didn't know who was running for supervisor in San Francisco. What did my vote matter? And so I would vote.
Well, Election Day is next Tuesday, in case anyone didn't know that. And thank you so much, Kate. What a wonderful event and talk and conversation. Thank you so much for coming.
Thank you all for having me. Thank you for having me.
A final thank you to Mary and Ellen for making this event possible. As always, we're so grateful, and I think this was a really special event, and I loved the personal connection that you described, Kate. That was wonderful. Last order of business is just to thank all of you for coming. We're so appreciative to have all of you here. Thank you also to the faculty, staff, and students who made this event possible. And finally, we hope, in addition to Election Day next Tuesday, there's also a lecture. So next Tuesday, November 7th, please join us for our lecture with Lena Gautama. And the full list of lectures and events for architecture are at architecture.mit.edu and act.mit.edu. See you next time. Thank you.